All right, we are right at the start time, 2 o'clock Eastern Standard Time, so we will begin. First off, good afternoon. I'm Jason Thomas, Project Engineer at America Makes, and I'll be your host for today's America Makes TRX webinar series. Little background on the TRX webinar series before I introduce our speaker. As America Makes continues its mission to expand and accelerate the footprint of additive manufacturing and 3D printing, this medium called the America Makes Technical Review and Exchange webinar series was created. Excuse me. By creating this platform, it allows the additive manufacturing and 3D printing community to come together and share knowledge and experience with the broader community. If you or your team are interested in presenting during the TRX webinar series, there will be a link to complete the request form at the end of our series today, or you can just go ahead and contact the America Makes TRX webinar series administrator, Jason Thomas, directly. A few important notes before we kick off the series. At the end of the presentation, there will be an opportunity for a brief question and answer or Q&A. If during the presentation you have a question, please submit it in the Q&A space on your WebEx screen, and we'll ask it during the Q&A session. I will do my best to get all of the questions answered. Today's webinar is on multi-metal 3D printing by Meltio. Without further ado, it is my pleasure to introduce Yash Bhandari. Yash works at Aditech Inc. as a business development manager in the additive manufacturing group. Yash has 10 years of experience in metal AM, and he possesses a unique blend of business and technical savvy, a big picture vision, with the drive and flawless execution to make that vision a reality. His current work at Aditech involves overseeing the sales, AM projects, and business development. He received his PhD in manufacturing engineering from Cranfield University in the UK. He also gained experience working for Tata Motors Limited in India as a technical manager in the AM department. Also for Oak Ridge National Lab and EWI as a subject matter expert. He holds 2 provisional patents in his name. He published several articles, chaired various conferences, and gave numerous talks on AM. He is an editorial board member of ASTM journal Smart and Sustainable Manufacturing, and he actively participates in the ASTM F42 committee and in ASM International Emerging Technology Committee. Yash, I will now turn it over to you and your team.
Awesome. Yep. Thank you very much, Jason, for the introduction. And thanks also for inviting Aditech for the America Makes TRX webinar. Okay, without further ado, let me jump straight into the presentation. Today's agenda will be very simple. I'll be talking about what is Aditech, what's how Aditech evolved as a key player in the additive manufacture. Talk a little bit about its history and the business model. And then I'll directly jump into what's our involvement with Meltio and talk about Meltio's technology, especially dual wire capability technology. And then I'll talk about the applications with some case studies. And then where Aditech looks into the future. And then I'll leave 10 to 15 minutes for Q&A session. Okay. So yeah, talking about Aditech, it has been a roller coaster ride. Aditech started in 2015. It was founded in Nevada. Right from day one, Aditech's goal was to innovate how metal components are manufactured. Especially in this generation, in the last few years or so, there have been a lot of innovations from additive standpoint. But 2 things which stand out are reliability and cost. Not all of these techniques, from reliability and cost standpoint, they're not up there. So that is why people are not yet adopting additive manufacture in their companies. So this was the ultimate goal. So during this process, Aditech developed prototype systems. It patented LMD wire process and came up with novel solutions, novel systems. And then it wanted to commercialize its technology. So that's where a Spanish company named Signova 3D comes into picture. And Aditech and Signova joined the forces together and formed a joint venture called Meltio in 2019. And then right from day one, Meltio's business model was to sell hundreds and hundreds of systems all across the globe. So for that to happen, it created a nice ecosystem with all the channel partners and all the distribution partners. And it's no brainer that since AddiTech is a co-founder and developed this technology, we became the master reseller in North America. And then time difference between AddiTech and Meltio was about 9 hours. So we wanted to reduce the time difference, which is on the cap. So that's why we moved to Florida, and then most of our customers are also based out of East Coast. So that's why we moved to Florida during the early part of this year. And yeah, we're right up there. We have a very big facility. In Florida, we are based out of Palm City, which is not far away from West Palm Beach Airport, about 15 minutes. And we have a big facility. We can see all the Meltio's systems, and yeah, we're going big. So what's our business model? The business model of AddiTech is very simple, to promote Meltio's technology in North America. And then the second business, unit of AddiTech is, print components on demand. Because this is a very important, step that we have taken this year. Because of the sole reason that additive manufacture and metal additive manufacture is still in nascent stage, although it has taken giant steps forward. But still, for everybody to adopt this, it's still in the early stages. So everybody would like to, see the demo components, see their parts printed. So that's why we have started this second business unit of printing parts on demand. So, and then this complements our first business unit, which is, promoting and selling Meltio's systems in North America. And since we are master resellers, we also have channel partners in the form of value-added resellers, integrators, and standard resellers. Like I said, we like working on innovative applications. We work with universities. We write joint proposals, SBI proposals with industries, and other grants like DOE grants as well. So yeah, apart from selling systems, we are also working with universities, writing joint proposals and print parts on demand. So what's the current status? So what has AddiTech achieved for the last few years? Well, a lot of things. So right now we installed more than 35 systems in North America. Well, it's close to 40 now. That's the current number. But yeah, until the end of Q1, it's 35 systems, most of them directly and also working with our partners indirectly. So our customers, they range right from universities, research centers to different industries coming from different sectors like aerospace, nuclear, automotive, you name any sector, in every sector they have one or the other Meltio systems. And then, like I said, we also like working on applications and projects. We've executed more than 20 projects, and not one of them is like project. So that is why we like working with innovative applications. So we are very well expertise in developing process parameters, building parts and qualification QA and QC for new metals, new materials in additive manufacture. Yeah, over the last 2 years or so, we have been working on different materials, right from steels to titanium alloys to nickel-based alloys to even some proprietary and sensitive materials from our customers. Okay, so yeah, so the topic of today is Meltio's dual wire metal technology. So, so you might be wondering why additive manufacturing is not yet 100% adopted. In my understanding, there are three main reasons why additive manufacturing is not yet adopted by small, medium, large scale companies. Um, just for the sole reason is that the cost of these systems, okay, the cost of these systems are very high. In additive manufacturing market, most of the systems are powder-based systems, and the cost of powders, the running costs, and the development costs, for running these powder-based systems are also very high. And then these systems are not capable of manufacturing large-scale applications. In our daily life, we come across small scale to medium scale to large scale applications. So these traditional powder based systems are not capable of manufacturing large scale components, and even the components that these processes make are not the best in terms of part properties. How are the mechanical properties turning up? How are the defects? And then, not the least, just the experience itself. I had both wire and powder hands-on experience, and just from my experience itself, working with powder is cumbersome in a nutshell. If you have to change the powder from one material to other material, it takes at least like 1 to 2 business days, and so much of equipment is required, like the PPEs and the masks. It just makes the operator's life very difficult. So this is why this is why Meltio wanted to develop a technology where it can, move from just a laboratory environment, or just move from prototyping, or only from one-off to, making parts in batches. How can we, produce these parts? How can we produce these parts in thousands and thousands of components, and then be ready for the industry? That is why it developed a technology, called Meltio as LMD wire powder technology. So this is a technology under DED, under directed energy deposition, and the process is very simple. LMD is not new anymore. It has been there in industry for more than 20 years, but primarily powder has been used as the feedstock. But on the other side, in additive manufacture, you can also use a wire as the feedstock, but there's no technology which can use both of them independently or simultaneously, because both of these feedstock have advantages. So that's why Meltio developed a technology, where you can feed both wire and powder independently or simultaneously, thereby leveraging the advantages of both wire and powder inside the single system. Although our systems are capable of feeding both wire and powder, we encourage our users to use wire because of so many advantages of wire compared to powder. Until and unless a material is not available in the form of wire, then only we encourage our customers to use powder. But other than that, 99% of our customers and our applications are manufactured using wire DED process. So what are the benefits? What are the benefits of wire-based laser metal deposition? Okay, I mean, like I said, although we started as a both wire and wire powder technology, but just from the experience that we work, that we are getting from the customers, it's obvious that there's a lot of push for high productivity and then efficiency of the process itself. So that's why wire DED, in my understanding, is the future for printing medium to large scale components. Just for the sole reason, wire is the safest and cheapest additive, feedstock in the additive market, because there is no material waste. So that means the efficiency is literally 100% when you compare with powder-based processes. Especially in powder DED process, it's only like 50 to 60% efficient, and then you have problems of recycling, or you have to just trash it away. So, but in case of wire-based DED processes, everything gets into the melt pool. So that means it is cleaner, greener as well. And then the cost of wires are at least one third the cost of what you find in the form of powders. Like for example, titanium. If you want to acquire 1 kilogram of titanium, it costs about $50 compared to $150 when you purchase in the form of powders. And then the productivity as well. If you are printing a similar component using wire and powder, it takes at least 3 times more time, when you're printing using powder as opposed to using wire. Probably these are the reasons why we think that wire-based DED process is the future. And then everybody complains about the surface finish when it comes to wire DED, but in our case, we achieve very good surface finishes because of the sole reason that we use laser as the heat source as opposed to arc or electron beam. Traditionally, lasers, they give the best surface finish. That's what we find in the literature. And because you have a nice spot size where you're able to concentrate your heat over the spot size, that means you're not putting too much of heat as what you find in arc-based processes. So that is why it results in low penetration and it gives better surface finish and good properties when you compare with other heat sources. So yeah, so that is why wire laser gives you the best surface finish when you compare with wire arc or electron beam wire processes. So as you can see in the picture, so this picture on your left hand side, it shows you what kind of surface finish we are able to achieve in our process. You can clearly see the contours, and it pretty much looks like like a mirror finish for me. This is made out of titanium, and you can hardly see any tessellations or any staircase effect which you would normally see with wire DED processes. So this process, you can use it to make small scale applications like what you see here. This is a very good example of a small scale application. So here what you see are watch bezels, and this is for one of our customers in the US. And yeah, you look at the surface finish and the size of the components. So yeah, it can be used to make small scale to medium scale to large scale applications. And then we understand about the bite-to-fly ratios. So that is why we just give only 1.5 millimeters as an extra stock, so that that can be final finish machine so as to achieve the right tolerances and then the right surface finishes. And there are so many applications also that we came across where we don't have to do any final finish machining. If it is a structural component, for example, you can just use as is. Or there might be some situations where you will only do final finish machine only at certain sections as opposed to the whole component. So how are we able to get to these good surface finish and high efficiencies? So this is because of the proprietary laser head developed by Meltio. So this is where all the black magic happens, and let me tell you some unique features of this dual wire deposition head. So the first feature is the wire comes out coaxially. Okay, so you got wire for feed nozzles and then off-axis lasers as well. So having this coaxial wire feed will make your life very easy, the user's life very easy, so that the directionality issues are completely eliminated. There are some technologies where you have this wire coming off from an angle, but in those situations, if you move in different directions, the melt pool size is pretty much compromised. So, but in case of coaxial, it's like a MIG torch. You can print any geometries in any direction. And the second thing is we got these off-axis, like 6 off-axis lasers. So these are fiber-coupled diode lasers. And each one of these lasers are capable of emitting 200 watts of laser power. So the total laser power is about 1.2 kilowatts. And the best thing about these arrangement is, each laser can be independently manipulated. Okay, so the max laser power is 200 watts, but you can assign, any laser power to each of the lasers. So this makes me imagine about melt pool shaping. So that means you have these 6 spot sizes, and you can assign different laser powers to each one of these. Essentially, you are fiddling around the heat distribution around the melt pool. I know a lot of customers haven't explored this option, but this is a very important feature when it comes to manipulating heat distribution around the melt pool. You can have one spot to be at a higher wattage compared to the trailing spot, where thereby you're giving some kind of preheat, and then you're also manipulating the solidification because you've got different laser power. So all of these things makes this deposition head very unique. And you can feed not only one wire, but more than one material, but only one material into the melt pool at a time. So that means there might be some situations where you want to print the lower section of a component with the material A, and the upper section of the component with material B. So that is possible, and it is done entirely through an automated fashion. So this Meltio system is a very good demonstration of multi-metal 3D printing. We have printed parts where we used a cheaper material on the inside surface, and then the right relevant material on the outside surface as well. So you can use any two materials as long as they are compatible from a welding standpoint. And then you also have got some closed loop feedbacks inside this laser head, basically to make sure that the layer thickness is maintained constant. So yeah, all these features put together give rise to this unique dual wire deposition head, which is capable of manufacturing alloys out of steels, titaniums, nickel-based alloys, or any other material that is available in the form of welding wire. And it gives tremendous advantages and gives good productivity compared to other powder-based systems. Okay, so what is the workflow? For every additive manufacturing process, we'll have a workflow, and we also have a workflow. But the good news is there are only 3 main steps in order to print a part. First step is what I call it as a digitization. Digitization applies to any other AM process. It's basically preparing a CAD model and uploading it to a slicer. Thereby, you get the tool paths. So those tool paths are then transferred to the machine, which is what you can see in the second step. Basically upload those G codes to the machine, and then select the process parameters, and boom, you start the printing process. And then the last step is taking out the part from the printer itself. Okay, so in most of the situations, you can use the as printed component itself, because the as printed component itself is more than 99% density, and it has all the right mechanical properties, where you don't have to do any sintering, curing, or any other secondary process. There might be some situations where you would need, for example, if you're thinking about an aerospace application, you want to have the high tolerances, nice surface finish. So for those type of applications, there'll be one additional step, which is one final finish cut on the CNC machine. And then depending upon the specs, there might be applications where irrespective of properties that you achieve on the printed part, you will have to do heat treatment. For example, aerospace components. So yeah, so these 3 are very simple, easy steps. Just from my observations, working with a lot of customers, and what I hear from the customers is it's very easy to run this machine. You don't need to have master's or PhD degrees to operate this system. Just a bachelor pass out is also good enough to run these types of system, because it's easy to learn. The slicing software we provide is also very easy to learn, and operating the system is also very easy to operate. Okay, so I just want to show you how the 3D printing process looks like. So we have different systems depending upon the geometries, but the good thing is that technology is same. Okay, so here what you're seeing is a wire deposition inside one of our small scale printers, which I'll introduce in the next slide. But the good thing is you can use any wire as long as it is available in the form of welding wire. And here you're seeing titanium 64 deposition. And yeah, as you can see, the surface finish, it looks very good. You don't see any staircase effect or articulations. And the process is also at least 3 times faster when you compare with powder bed technologies. So it took us like close to 40 minutes to print this particular component, and the cost of making that is only like $20. That includes the cost of wire, cost of plate, and argon gas. So these are the 3 different systems, where you can make right from small scale to medium scale to very large scale components. The first system is the M450. You saw the video; it was recorded inside this M450. But you can make components of dimensions 150 by 200 by 450 mil in Z direction. It's a very good machine if you just want to understand more about the wire DD, print small scale components, or do some research activities. On the other side, if you want to build industrial components, larger components, then CNCs are suggested. So these systems are called hybrid systems. So basically, what we do is we attach our additive tool or the laser head to the already existing CNC system, and then using the same system, you can do additive and subtractive on the same platform. So this cuts down all the lead time. You don't have to move the printed component from one platform to other platform. You can do everything in one place. And then our third system, this is my favorite, which is a robotic system. The reason why I like the robotic system is, you can make all complex components. The size is not at all a limitation. You can make as large as 2 meter in length components. Which might not be possible on CNCs, because the size is pretty much restricted to the size of the machine. But on the other side, on the robotic system, you have 6 axes, which comes by default, and you add a positioner, and then you're giving 2 more axes of freedom, and basically you can make any complex geometries using these robotic system. And learning robots is very easy, and operating the robots is also very easy. So let me show you how the hybrid systems look like. So what you see on the left-hand side is the arrangement, how the laser head is attached to the spindle. So we have a nice deployment mechanism, which we call, where on a need basis, you would turn on the laser head, and then the laser head comes and stands at the right standoff distance. And once you're done with additive manufacture, it directly goes back and then it shuts it off so that the laser head is safe from chips or any other impurities. And then the right side, what you see is 3D printing process itself. So yeah, with the help of one M code, the laser head comes and starts the printing process. And once you're done with printing process, you can start off the machining process. Although it's present inside the CNC machine, but it still looks like an invisible. You're not compromising on the CNC functionalities. You're not. So this laser head does not, come in the way of the CNC movement at all. Okay, so moving on from CNC to, let me show you one more application, which is a very important application in the additive market, is the repair application. We have been getting a lot of inquiries for feature additions and repair applications. So here in this video, what you're seeing is that we are adding a feature on top of already existing element here. So there's a cylindrical bar, and we are adding an elbow-shaped pipe onto the already existing cylinder tube. So this kind of feature is not present with powder bed technologies. It's very difficult to add features on a powder bed, but especially using wire DED or on these Meltio systems, it is you can add these features, you can repair these components seamlessly. Okay, and then moving on from CNC to the robotic system. So like I mentioned, with robots, you get these 6 degrees of freedom, and you add this positioner. You basically got 8 degrees of freedom, and you can make these crazy components like coils or large scale applications seamlessly. So yeah, and different alloys require different setups. So here what you're seeing is a stainless steel, and you can also deposit titaniums, nickel-based alloys also. So we are like a one-stop solution. If somebody has a robotic system, no problem. Even if somebody doesn't have a robotic system, we can provide, and we can install the robotic cell and then integrate everything. We just recently finished installation at one of the customer sites in Georgia, and we are seeing a lot of interest, especially on the robotic side, because you can make small, medium, and large scale applications, and it gives you a nice, wide range of applications and different geometries that might or might not be possible with other AM processors. And one more example that I want to show you. Here where we are using the positioner table, and we have this laser head pretty much vertical all around the process. So these type of components will take several months. When you take 3D the conventional processes like castings or forging. And in case of 3D printing, you're cutting down the supply chain. We all understood, how COVID has disrupted the supply chain, right? So using this additive manufacture, using our system, you can negate all the supply chain issues and print these kind of parts within 1 week or so. Okay, so couple more capabilities of the Meltio's technology is, as I mentioned, the dual wire capability. You can switch between 2 materials within the part building, as many as like as you can in this picture you would see like at least like 1,000 different times. So this picture you see 2 different materials, mild steel and stainless steel, and moving from one material to other material is completely automated. And even on the other picture, what you see here, you can print. We have shown using this dual wire capability that you can save 90% of the total material cost and time. And another feature of our technology is the hot wire capability. So what exactly is this hot wire? Is using resistive heating, we heat up the wire before the wire gets into the melt pool. So there are different advantages of using hot wire. One is it gives you better process stability, and using this hot wire you can put more material during the printing process. Thereby, you're increasing the productivity. So all of these features make this technology very much attractive, thereby saving a lot of time and a lot of material wastage, and then you can build these components using at a very relatively lower cost compared to conventional manufacturing. Or there might be some situations where it is not at all possible using conventional manufacturing like forgings or even machining processes. So yeah, in a nutshell, Meltio's technology can be used to make high resolution parts. As you can, this is a very good example to show, the cooling channels. How Meltio's technology can help print this type of components, and you can also make repair applications or feature additions, and you can also do large scale applications and perform laser cladding as well. So all of these features are come by default with the Meltio's systems. So yeah, different applications. So it's versatile. I know a lot of people who ask, what's your favorite sector that you would use, this technology for? I mean, my answer is it's versatile. You can use it for aerospace applications, to energy, to marine and heavy industries as well. Like all we care about is the geometry. If the geometry is good enough for our process, it can be printed using that material. And in all the situations when we drive the business cases and return of investments, when you compare with conventional manufacturing, we are lowering the costs and time by at least 30 to 50%. So these are a couple more examples of what we are capable of working with. So one thing I would love, I would like you to see is different materials, different material portfolios. Meltio supplies its own, wires, but good thing is it's an open materials platform. That means you can use the wires from any supplier. Although we provide, because we completely understand that there is long lead times for procuring these materials. So we have a good, nice batch stock of wire lying around, so we can share it with the customers. And the good thing is we also share process parameters free of cost with the Meltio wires. But again, you can use external wire, vendors as well. So yeah, here in this slide, you can see different materials we use, and a lot of other confidential parts that I'm not showing it to you, but this just gives you an idea of the type of materials that you can use, right from steels to titaniums to nickel-based alloys to even refractories like molybdenum as well. Yeah, as I mentioned, our second business unit is working on applications, and we use Meltio's technology to build these innovative parts for our customers. This is a real life component that we built using Meltio's technology. So this was a joint effort between AddiTec and Amorphology. Amorphology is a NASA spin-off company based out of California, and they used to. So the conventional method was about 3 months of manufacturing time and costed a lot of dollars. And using Meltio's system, the cost and time both come down tremendously. So this was the 3D printed part, and this was final finish machined to the final component. So thereby we are reducing the total cost and time by about 50 to 70%. So this was a press release done a few months ago. That was in February. So we started off with 17.4. So there aren't too many processes that can do 17.4, because 17.4 is not easy to weld, and it's one of the expensive metals. But we managed to print these using 17.4 and reduce the cost. So for us, not just the geometry, but also the properties are also important. So the reason why I'm showing you this property, the set of properties, is a lot of people complain about additive manufacture being not yet there in terms of achieving the specs, but not anymore. Using our laser wire process, we are able to achieve very good properties, and very much reduce the variance in getting suitable properties in different directions. As you can see, X and Y properties, there's not too much of variance that you would normally see with high heat input process parameters. And then we leverage the first stage of the applications to to ultimately build the right desired component using two different materials. So this was again the project, the continuation project with amorphology, where if you look at the component, the main section that they're interested is the gate tooth profile, and that's where they're interested in getting better properties. But at the same time, how can we lower the cost of the total component? Because 17.4 pH is a slightly expensive material when you compare with other grades of steels like stainless steel, for example. So the question was, can we build this component using two different materials and get the right properties? So the answer is yes. So we printed this component using two materials, at the same time achieve the desired property. So the bottom section was built using stainless 316, and then the top section, which is where the teeth profiles come into picture, was printed using 17.4. And then moving from one material to other material was also very much seamlessly. In a matter of 6 seconds, you can move from one material to other material. So we are not stopping altogether, and it's done entirely in an automated manner. So yeah, these are the different types of applications that we work. And if there is any application, any part that you would like us to analyze, build it, create a business case, I'll be more than happy to work with you. Okay, another example of multi-metal 3D printing. One of the main drivers for multi-metal 3D printing is cost, the cost reductions. Okay, so here in this picture, in this video, this is again a real life engineering structure. So this component was printed using two different materials, mild steel and tool steel. And yeah, the cost of tool steel, as we all know, it's slightly higher compared to stainless or mild steel. But at the same time, we didn't compromise on the even on the property. So the lower section was built with mild steel, and then the top section was built with tool steel. So mild steel and tool steel, there were a couple of sections where within a layer itself, both of these materials were applied. And what about other materials? Yes, we tested different materials, the most commonly used materials like stainless steels, titaniums, nickel-based alloys. And the good news is when we compare the properties that comes out of these printed parts, they are very much there. When you compare the casting and rod properties, like in my understanding, our competitors are not additive systems. Our competitors are just the conventional manufacturing, like forgings, casting, because they take up a lot of lead time, and because time is money, right? You got to wait, and they have a very complex supply chain. So this is where a technology like Meltio's technology will disrupt in a positive way, cut down the total lead time and cost. And then the properties are also better than casting. And even in casting, you still have to do one final finish cut, which is something we also do in most scenarios. But the good thing is, you're not only saving cost and time, but you're also enhancing mechanical properties. So this is the third advantage of Meltio system. Not only it reduces the cost and time, but also enhances or replaces the highly expensive materials using relatively affordable material, but still achieve the right mechanical properties. Okay, so where does Meltio's technology lie in the midst of 10 to 15 other additive processes? It lies at a good, nice sweet spot, since you can use both wire and powder. So you can check mark powder DED parts, and also you can check the wire DED parts as well. In most of the situation, until and unless we don't find a material in the form of wire, that's when we go for powder. And but in most of the situations, wire DED reduces the total time and cost when you compare with other processes. So in terms of speed, we are at least 5 times compared to powder bed fusion processes, and we can make large scale parts as well. Okay, yeah, I'm coming to the end of my presentation. So where does so what is the Meltio's technology can be used for? Can be used for a lot of a lot of applications. If you want to do research, sure. Like at least like 20 to 30% of our clients are from universities. They like this technology, and then they have our systems and they do a lot of research looking into these basic sciences and material interactions. You can do one-off parts, no problem. We have customers coming from bolts and die, where you make only one-off dies, right? And we also have customers coming from service bureaus where they make parts, like thousands and thousands of parts per year. You can use our systems even for those. So yeah, in a nutshell, you can do 3D printing, you can do hybrid manufacturing, and you can also do repair and feature additions as well. Not but not the least, the cost of these systems, which is one of the bottleneck for AM adoption in industry. The costs are also very much affordable. Our prices are they range anywhere between 200,000 to 400,000, depending upon which system and options. But I think you're not looking at saving a few $100s, but it's order of magnitude when you compare with other systems which are like 1 million, 2 million, or even 3 million. So here you're looking at 200,000 to 400,000 and get the same same level of quality from the 3D printing standpoint. And then you don't need to have any auxiliary equipment for curing or sintering or tumbling. Just the as printed components are good with the properties. And then since you're using wired, you can use these systems even in office environment as well. The robotic system, of course, in an industry setup, but the M450, for example, you can use it in an office environment. You don't have to worry about the health and safety. Okay, so what is the future of AddiTec looks like? So yeah, still the main priority is promoting Meltio's technology and systems in North America. So that'll still be our foremost priority. Second thing is we have been developing innovative solutions for manufacturing these components. So that's our second goal, and we're coming up with new systems. So we have an open door policy. If anybody would like to visit our facility, please feel free to pop up. We would love to host you, and we'll be there at different expos, conferences, Rapid next week. And then the following week, we'll be there at Space Tech. And then in June, we'll also be there at AM Industry Summits. And we love, promoting this technologies through webinars. Thanks to America Makes as well. But we'll always be, doing a lot of, webinars, doing a lot of press releases, what we are doing innovatively compared to other companies. And we see this as a future that will disrupt the way how components are manufactured. Okay, so this gets to the end of my presentation. Thank you very much for your time.
All right. Thank you, Yash. That was a great presentation. Very, very informational. We're now going to go ahead and head into the Q&A session. So if you haven't already, and you do have a question for our presenter, please type it into the Q&A, and I'll try to get it asked here. So we got a couple here that came in already. So I'll start out with this one. Oh, sorry about that. All right. So could a hybrid wire and powder nozzle be integrated into a CNC machine? And then a related question was, I think it was almost the same question. Can you add a laser head to an existing Haas machine?
Yes, you can add our tool to an existing Haas machine, no problem. We have integrated to several Haas models, right from TM1 to UMC 1000 to a couple of VAF models as well. So yeah, any Haas model or any CNC brand, I would say, our laser heads are compatible with. And then with respect to wire and powder, I think it's only wire we are offering when it comes to CNCs. But the good news is we offer wire and powder for robotic systems. just for the sole reason that the powder gets all clogged up in the guideways for the CNC, and it might compromise the functionality. So that's why we only offer wire solution when it comes to CNCs. But with robotic system, we offer both wire and powder. And then powder, you got to also understand that the health and safety aspects. So that is why only the robotic system has the capability to handle both wire and powders.
That's very understandable. So let's see, another one I got here. So how does the microstructure and final mechanical properties from wire-based DED differ from powder-based DED? And I think you might have covered this already, but are there any comparisons? And also, does wire-based DED require heat treatments to obtain the final microstructure?
Yeah, absolutely. Yeah, these two are, I get asked these questions a lot of times. Good questions. So when you compare wire DED properties compared to powder DED, there is a difference. There is a difference because the microstructure is the one which defines mechanical properties, and then microstructure is defined by the cooling rates, right? So in wire DED, you would use a slightly different cooling rate compared to powder DEDs. And then just the feedstock itself. So here you're using wire, which is present in the form of a filament. But on the other side, powder, which is present in the form of fine particles like 50 microns to 150 microns. So because of this large surface area, the powder has a lot of chances of attracting moisture or getting oxidized. So probably this is one of the reasons, why powder DED components have porosity issues. And then on the other side, in wire DED, the melt pool size is slightly larger compared to powder. So that means if you want to fill up a section in wire DD, you will do like, for example, 50 passes compared to 100 passes, what it would do for powder DED technology. So more the number of passes, more are the odds to get lack of fusion defects. So probably, I mean, everything adds up, the porosities, the lack of fusion defects, in order to achieve, good mechanical properties. So that's why I would say, for especially wire DED gives you better mechanical properties compared to, powder DED, especially from porosity and lack of fusion defect standpoint. And on the other side, heat treatment, yes. Heat treatment is necessary depending upon the application. So applications like, for example, aerospace applications, for example, they have stringent, criteria, whatever might be the printed properties, you still have to do heat treatment. And of course, we all know that heat treatment gives you enhanced mechanical properties, when it comes to the elongations, like additive manufacture has a very bad reputation when it comes to elongations. For example, if you want to have nice fatigue properties, I think heat treatment is necessary. But again, we tested, we evaluated a lot of our alloys. We didn't use any heat treatments for steels or nickel-based alloys, but we still managed to achieve in fact like 10 to 20% more than the specs what is required actually. Yeah, in case of titanium, yes, we all know the characteristics of titanium. So for titaniums and other alloys that are more prone to oxidation, I think heat treatment is necessary. But good news is, we are not reinventing the wheel. We are using the already existing cycles, the heat treatment cycles from welding, and then applying it to DED processes.
All right, great, thank you. All right, so we got another one here. So first of all, thanks for the presentation. And then the question is, can we measure the temperature of wire with the hot wire function?
No, the short answer is no, as of now. As of now, we can only manipulate the heat that is getting into the hot wire, but we can't measure the heat and the temperature of the wire that gets into the melt pool. But we do a rough calculation of the temperature. We just use the already existing heat transfer equations to predict what kind of temperatures the wire will be going up to actually. And then again, we're not giving too much of heat as well. We just want to bring up the wire from the room temperature to, let's say, 100, 120 degrees. And then all of these will give you benefits from microstructure and good process stability standpoint. But yeah, answer to your question, we don't have means as of today to measure the temperature of the wire, but we forecast it using the heat transfer equations. But at least it gives us a rough range, if not the right temperature.
All right, thank you. All right, I guess one more. We got time for about one more here. So while building a part, can one switch between powder and wire in the same layer? And can one switch between powder and two different wires in the same layer?
Yes, absolutely. Yes, and yes for both of the questions. So when we are printing, using robots, that's when powder comes into picture. Yeah, you can have both wire and powder, simultaneous deposition, or you can have both of them within the same layer, independent deposition. And then even if you want to change from one wire to other wire, it is possible within the same layer, but it's only one wire that gets into the melt pool at a time. And then moving from one wire to other wire is completely automated and seamless, and it happens within a few seconds.
All right, great. Thanks, Yash. That was very helpful. All right, so I think that's going to wrap up the Q&A, and that's also going to wrap up today's TRX webinar series. I would like to once again thank Yash, and if you have any further questions for him, please reach out to him directly. He has his contact information there in the bottom left hand of the screen. As a reminder, if you think that you or your organization will be interested in sharing on the TRX webinar series, please fill out the form that follows the presentation, or you can reach out to me directly at jason.thomas@ncdmm.org, or you can visit our website and you can fill out the form there. And then don't forget to register for next month's webinars. On the 8th, we have Xerox, Emerging Technologies, liquid metal print jetting. And on 6/22, we have Vibrant with good vibrations, process compensated resonance testing, or PCRT, for additive manufacturing inspection. Yash, thanks again, and everyone have a great day.
All right. Thank you very much, Jason. I really appreciate you guys inviting AddiTech for this TRX webinar. We really appreciate you.
Yeah, anytime. Thanks, Yash.
All right. Thank you very much. Cheers.
Bye.